What if I told you there's a technology so advanced, so revolutionary, it could solve literally any problem? From climate change to traffic jams, to why your AirPods keep disconnecting at the worst possible moment. Welcome to quantum computing, a new kind of computing that uses mind-bending principles of quantum physics to process information. Unlike classical computers, which use bits, zeros and ones, to perform calculations, quantum computers utilize quantum bits, or qubits. Qubits can exist in multiple states simultaneously and become entangled, allowing quantum computers to solve complex problems exponentially faster than classical systems in specific domains.
That's right. We're talking about computer power millions of times greater than what you can get from an ordinary transistor, which is either off or on, off or on. We're talking about millions of times more states than computer power in a quantum computer, which is going to revolutionize medicine, energy, space travel, transportation, you name it.
That was Michio Kaku, a theoretical physicist at the City College of New York and best-selling author of Quantum Supremacy, telling how quantum computers work and the amazing things that can be achieved with quantum computers.
These quantum computers are so powerful that for chemistry, you don't need chemists anymore.
Here's expert John Preskill, director, Institute for Quantum Information and Matter, Caltech, in an interview in 2024, talking about some of the progress in the world of quantum computing.
Part of what's significant compared to, say, 5 years ago is now we have systems that have more qubits and higher quality qubits, so we can do computations that we couldn't do 5 years ago.
Did you know that Microsoft announced that they had discovered the first processor to achieve this revolutionary change in quantum computing? And it is the Majorana 1. And that's the story I want to share with you, so sit tight, put on your seatbelt. This ride's going to be bumpier than your aunt's dating history at family dinners. Ever wonder what happens if a tiny particle is also its own opposite? No? Good for you probably have hobbies. But in the world of quantum science, that kind of particle is called a Majorana fermion, and it could totally change how we do quantum computing. In 2023, Microsoft said they finally found real signs of these weird particles. That's a big deal, because they might be the key to going from today's clunky 400-qubit computers to a million stable qubits, all thanks to a particle that's basically its own twin and enemy at the same time. Welcome to the wild world of Majorana 1, the road to a million qubits. Let me add that 96% of quantum computing researchers mispronounce Majorana in casual conversation. How did the world come about the Majorana particle? Back in 1937, Italian scientist Ettore Majorana had a crazy idea. What if there's a particle that's also its own antiparticle? That's like saying something is both a thing and its opposite. Then, in 1938, Majorana took a boat trip and disappeared. No one ever found him. Super mysterious. Anyway, scientists kept looking for these particles he described. They had no proof for over 80 years. In 2016, Microsoft decided to go all in. Instead of making bigger but noisy quantum computers like Google or IBM, they bet everything on Majorana particles. The false start. Back in 2018, a Dutch research team said they'd found Majorana particles. The science world got excited. Then, whoops, they were wrong. By 2021, they had to take it all back. The retraction was formally published in the journal Nature in 2021, where Leo Kouwenhoven and his co-authors acknowledged inconsistencies in their data analysis and apologized for insufficient scientific rigor in their original manuscript. So they basically pulled a, "We found a giant gorilla," then realized it was just Dave in a furry coat. Yup. And it was a huge embarrassment. Major science papers got retracted. Careers were shaken. It was like promising the moon and delivering a flashlight. This made people wonder, was Microsoft betting on a fantasy? Like putting all your money on Bitcoin in 2010? Yes, but then the breakthrough. In March 2023, Microsoft made a big announcement again. This time, they really saw signs of Majorana zero modes. Not just once, again and again in different setups. How sure were they this time? As sure as science gets. Here's a crazy stat. They were able to control individual electrons with precision, down to 0.001 nanometers. That's like placing a marble anywhere on Earth with millimeter accuracy. They used supercooled nanowires and precise magnetic fields, like quantum tech on expert mode. Here's Microsoft's Chetan Nayak, General Manager for Quantum Hardware Microsoft, at the insightful presentation series from the Quantum Matter International Conference 2023, a leading global forum held in Madrid in May 2023, talking about the breakthrough.
So we need better qubits. That's why we're excited about the topological approach, because it is an approach to getting qubits that are more stable and have a small footprint and get fast gate speeds.
Why topological quantum computing matters. Why does it matter? Because these particles could power a totally new kind of quantum computer, topological quantum computers. That's our next stop. Today's quantum computers are like 1980s cell phones. Cool, but super limited. They get messed up by noise and lose information fast. Like trying to binge watch your favorite show with your little cousin screaming in the same room? Exactly. To fix that, they use a lot of backup qubits. Like, a lot. Sometimes thousands for just one reliable qubit. That's like needing 1,000 friends to help you send one text, which makes scaling up nearly impossible. But Majorana-based qubits are special. They protect themselves from errors, like having built-in noise canceling. If it works, you might only need one physical qubit per useful qubit. Suddenly, a million-qubit computer doesn't sound so crazy. So the computer basically babysits itself. What's next? So, what's Microsoft doing now? They're working on braiding these particles, moving them in special ways to perform operations. It's like writing code by braiding invisible threads in space. By 2028, they hope to have a working small quantum computer. By 2030, thousands of qubits. And by 2035, the full million-qubit dream. If they pull it off, we could solve huge problems, designing new medicines, cracking super complex puzzles, and running simulations that today's computers could never handle. Could it make TikTok less cringe? Sadly, no. But for everything else, this tech could change the world. So, that's the story of the Majorana fermion, a strange particle that could lead to a massive leap in computing power. And remember what physicist Richard Feynman said, "If you think you understand quantum mechanics, you don't." But hey, you now know more about Majorana fermions than most people. If this video helped you out, smash that like button like you're trying to get the last slice of pizza from a hungry roommate. And don't miss our other videos on how tech is out to change the world. Your future self will thank you. Oh, and don't forget to drop a comment telling me what you think about the Majorana one.